In section 8.4, example 1, we're looking at how to classify angles. So here at the left, we're given a diagram. Over to the right, in part A, we're asked to name a pair of vertical angles. So vertical angles are formed whenever two lines cross or intersect. So we have one line here with line AD, and then we have another line here with line BE that look to be intersecting and crossing. And their intersection point is here at point F. So what we're looking for is we're looking to name a pair of vertical angles. So this angle here, which is angle DFE, so I'm going to label that as angle DFE, is going to be a vertical angle to angle AFB. So we need to write down angle AFB. Now, this is not the only vertical angles that we have in this diagram, but this is probably one of the most common that students would see. So these two lines, line AD, line BE, they're intersecting at point F. And so angles that are opposite to each other, which are known as vertical angles, would be angle DFE and angle AFB. Now, in the second example, they say name a pair of adjacent angles. So I'm going to erase my lines that I have here. And we're going to look at some vertical angles. So some adjacent angles. So adjacent angles are angles that are side by side to each other, and they share a common side. So if you look at it, we have an angle right here with angle CFD. And it's actually going to be, this angle is actually going to be adjacent to angle BFC. Now you'll notice that angle BFC and angle CFD, they share a common side here, a common segment, which is going to be here with FC. Now, when we look at this, this is going to be the adjacent angle BFC, and then angle CFD. When we talk about angles, we typically either label them as a small lowercase letter, or what we do is we label angles as a 3 points, such as BFC or CFD. Now, with the next part, we're going to go to part C. It says name a pair of supplementary angles. Now, when we talk about supplementary means that they equal 180 degrees. So the other thing that you need to know about this is that they are, when they're put together, they form a line. Okay. So when we look at this, they want us to name a pair of supplementary angles. So we can, when we talk about a pair here, we're meaning two. So what we're going to do is we're going to look at our diagram and see where we have a couple angles that would equal to be 180 degrees. So if you look at this, we have a line here with line BE. And if you look at it in this way, there is an angle here with angle AFB. Trying to draw that as straight as I can. And then we have another angle here with AFE. Now, when we combine angle AFB and we combine angle AFE, those two angles added together will give me 180 degrees. So a pair of supplementary angles in this diagram would be angle AFB and then angle AFE. And when we talk about these AFB and AFE, we start at those points A, then we go to F, then we go to B, and then angle AFE, we start at point A, we go to point F, then we go to point E, and we follow back and forth, and that's going to be those angles that we're referring to. Now, in the Part D, they say name two pairs of supplementary angles that include angle DFE. So when we're talking about this, we're talking about angle DFE. So we're talking about from D to F and then over to E. And so they want us to name two supplementary angles that include DFE. So if we're talking about trying to form a straight line, one of those could be angle AFE. So I'm going to label one of them as, I'm going to list one of them as angle AFE because if I combine that angle with angle DFE, it's going to give me 180 degrees. And then we need to find another angle. So looking at it, if we go from B to F to D, we have another angle there that if we combine it with angle DFE, that is going to give me 180 degrees as well. So I'm going to label the other angle here as angle BFD. And those two angles, when combined with, either one of these two angles combined with angle DFE, it's going to give me supplementary angles, or it's going to give me 180 degrees. Now, in the very last question that we have in this section, they want us to find the measure of angle AFB. So we're talking about from A to F and then over to B. So they want to know this angle, which they've already labeled here as X. Now, what you should see here is that if we have from A to D, that is a straight line. So we know that's going to be 180 degrees. And so if we look at angle CFD, at that particular angle, that's going to be a 90 degree angle because we have this little box looking area here. So this is going to be a 90 degree angle. And then if we combine angle BFC, which is this angle here, which is a 50 degree angle, with that angle that we're looking for, angle AFB, we know that's going to equal 180 degrees. So I'm going to say that that if we look at this, we're going to say X plus that 50 degree angle there at angle BFC plus the angle CFD, which is 90 degrees. All of those three things should equal up to be 180 degrees. So now all I need to do here is take 50 plus 90. That's going to give me 140. So I say X plus 140 degrees is going to be equal to 180. And then what I need to do is isolate my X by getting rid of the positive 140 by subtracting both sides by 140 degrees. The 140 degrees will cancel out on the left. That'll leave me with X equals, and then when I take 180 degrees minus 140 degrees, that's going to give me 40 degrees. So the angle there for AFB, when they talk about the measure of this, we typically will put an M in front of it like so with the angle sign. AFB, that little lowercase m in front of that angle, means the measure of angle AFB is going to be equal to 40 degrees. And then that would be answering all of our parts to this example.